Okay, we're going to look at the rational number class as just an example of how you can use Python to create new data types, to be able to solve problems that much more easily than before. So usually the way what this thing is about is the following. You have a particular problem, right? In this case, the problem is we want to have rational numbers. We want to be able to do the following thing. I want to be able to say something like, a, that is going to be some rational number that's representing 1/2. I want to be able to say rat A is 1/2. I want to create another rat. Let's say B is also a rational number. Let's say that is 2/3. So number one, I want the ability to create these things. I want to be able to say I have a rat C, which is also going to be a rat, and I want to be able to say that C is going to be equal to A plus B, or I want to be able to do this even without saying C is a rat. So that is the what question, right? The what question is what is it that I want to accomplish, and then the answer to that is going to be a how question, right? How is it that I accomplish it? And the answer in Python and many other languages is to create a class that lets you do that, right? Now, so for the class, I've got to decide two things. Number one is how the data is going to be represented, right? In other words, I have to think, what does the data look like? And then the second thing for these rats is probably going to be 2 integers or something. And the second question is what kind of operations is my rat going to be able, or my new class, my new data type, what kind of operations are going to be able to perform? And the way that we do this how is we use the class representation to create a new data type. That's basically the idea. So let's first take the first question here. How do we get Python to allow us to do the following thing? I want to be able to say I have a rat. A is the name of my rat, and so I want to be able to say A is equal to a rat, and that rat is going to have, say, the value 1/2. So we're going to create a class to do that, and in order to do this, Python provides us with a function, a built-in function that we have to define in our class. So the first thing we do is we say to Python, I have a class, and I give the name of the class. I say class rat. Then over here we're giving all the different functions. This is the init function, and this is going to be the add function. We're going to see some more functions as we go along. The init function is the one that's going to do two things for us. The first thing it's going to do is it's number one, going to create this rat. It's going to go into memory and it's going to create a rat, and we want the rat to look like this. It's going to have two parts, one for a numerator and denominator. And second of all, it's going to let us instantiate the numerator and denominator. It's going to, in other words, take the first value and put it over here, and the second put it over here. So let's see how the init function works. Basically, the init function looks like this, right? And it has 3 parameters. The first parameter is self, the second parameter is the numerator, and the third is the denominator. And we see that in Python here we have, for example, n is equal to 0. What n equals 0 means is that unless you give me a numerator, well, here I'm providing it with a numerator, right, 1 in this case, but if I don't provide it with a numerator, it's going to give me 0 by default. Likewise, the denominator is going to be 1 by default, but if I pass in the 2 parameters, here I'm passing in 1 and a 2, it's going to give me those values instead. So it's going to put a 1 over here and a 2 over here. Now, what are the name of these two fields, these two data fields? Well, since this thing is referred to as self, right, it's going to be the particular rat I'm creating, which is A. So I'm going to refer to this field over here as self dot, and you'll notice over here it's going to have an underscore numerator, and so self is going to equal to self underscore numerator self dot underscore numerator. That's going to be the name of this field over here, is going to get the parameter that gets passed in. Right now, it's going to get whatever value we pass in for the numerator. In this case, it's going to be 1, and then self dot denominator dot underscore d, which is going to be the name of this field over here. That's going to get the second parameter we pass in, which is going to be the d. Now there's only one more thing that's happening in this piece, and that is that, let's say, for example, someone says not 1/2, but someone says instead, A is going to be some kind of rat that is going to have a 7 for a numerator and a 49 for a denominator. What I'd like to happen over here is that when it sees 749, so the fraction 7 over 49 is not really in lowest terms. I would like to have this automatically be converted to lowest terms when I put it in here, so that should automatically come to be 1/7. So that's easy to do because there's a built-in function if I import it from the module called fractions, right? So right on the very top over here I say from this module called fractions import a function called GCD. GCD stands for the greatest common denominator. The greatest common denominator is the biggest number of the two parameters that I pass in. So I can say, for example, over here, greatest common denominator of, I pass in the two parameters, the numerator and denominator, it's going to give me the biggest number that divides both. So if I pass in a 7 over here and a 49 over here to the GCD, well, the biggest number that divides both 7 and 49 is a 7. So that's what's happening in this code here. First, f is going to be equal to the greatest common denominator. In the case of 7 and 49, the greatest common denominator is going to be 7. And then what it does is before it assigns the parameter to the numerator, to self.numerator, it's going to divide it, right? It's going to say take self.numerator, self._numerator, and assign to that, well, take n and divide it through by the greatest, by f, which is the greatest common denominator we just calculated. So that is going to give me, if I put a 7, it's going to give me a 1, and likewise self._denominator is going to equal to the denominator divided by the GCD, and so that's going to give me lowest terms. Okay, so that's basically the idea when I initialize my rat. That's basically what we do here. One other point of interest to notice is, let's say I do something like this. Let's say I say a is equal to rat 5. What happens over here? I mean, here we have two parameters, but I'm only providing one of them. So what it's going to do is it's going to take, well, you gave me 1, I'm going to assume that it's going to override just the first one. So it's going to take n equal to 5 and d equal to 1, and it's going to create for me a rat that looks like this, right? So there's going to be a 5 over here and a 1 over here, and that's in fact going to represent the fractional version of the integer 1. Okay, so that's how we create these rats. Okay, the next thing that we want to do is we want to do the add, right? The reason we're making these rats is because we want to be able to work with them, right? So working with them basically means doing some arithmetic. So once I have a rat, right, let's say I have a rat called a, and a is the rat 1/2, and b is the rat 1/3. I want to be able to create a new rat by simply saying a equals b, and then say c is equal to a plus b. I want to be able to do that. So in order to do that, I have to teach Python how to do the add, because of course it doesn't know that because it has no clue what rats are. So that's the add function that's defined right over here. Now you'll notice there's really two parts to it. We have one question if type other equals type 1, and then we have the else part. Let's look at the else part first. Let's see what this thing says. This is the standard case where I have two rats that I want to add. And just let's remember what happens when we want to add two fractions, right? So if I have a fraction, let's say k over L, and I'm going to add that to another fraction m over n. So when I add them, what happens is I cross multiply. I get L times m, and to that I have to add k times n, and I put that over L times n. Right? That's what happens. We do the same thing over here. But here our rats, if I have a and b, if I'm multiplying two rats, so then my rats really look like this. The first rat, which is going to be called self as it comes in here. Notice there's two parameters here. Self is the rat on the left-hand side, and other is the rat on the right-hand side. So when I want to add self plus other, so this guy here is going to be called self. This guy on the right is going to be called other. And both of these have numerators and denominators. Underscore numerator and underscore denominator, underscore numerator and underscore denominator. And what I want, let's say for example, this is going to be a and b, so this is going to have here 1/2 and this is going to have here 2/3. So how do I add them? Well, basically, this is my k over L, right, is the left-hand side, and the m over n, the second one, is on the right-hand side. And so the way that I refer to the numerator here is self.numerator, self.m, and here it's going to be self.d. Likewise, this is other.numerator over here, and this thing is going to be other.denominator over here. And so the way we're working over here is we're going to basically create the numerator and denominator, right? So that's what happens here. I create the numerator first by doing the same arithmetic that you see here, except with self.n and so on. I create the denominator over here, and then what I want to do is, since I want them in lowest terms, I get the greatest common divisor of both of those two things, right? The GCD of numerator and denominator. And then I take the numerator and denominator, divide through by the greatest common denominator. And what's supposed to come back when I add two rats? When I say a plus b, I'm supposed to get a rat. So I basically call this rat function, right? This we saw, this is called a constructor, because it's basically constructing a new rat for me, and what I'm passing in is the numerator and the denominator of the sum, right? I've created the numerator and denominator over here, and I'm passing in to the rat constructor, and then it returns this rat. So that's how, in the case of rat plus rat, in this case of a plus b, the plus will actually return the appropriate rat, and then we'll get assigned to the variable c. Okay, that's case number one. The other case, this case right over here, that's going to allow me to do the following kind of thing. That's going to allow me, right, this is number 2 here, that's going to allow me to do, I have a rat A, and I want to create a rat C that's equal to A, right, that rational number, plus, let's say, 5. I want to add an integer to a rat, because the idea is that I want to be able to incorporate my new rational numbers into the existing arithmetic that provided by Python. So here, I can't use what I did before, because this assumes that the parameter, that other, does have a numerator and denominator, right? If you look at what goes on over here, we say the denominator of other and the numerator of other and so on. Well, an integer doesn't. So what I need to do is I need to detect if in fact this thing here is an integer, and once it is, I can treat it in the appropriate way. Namely, I come over here and I say if the type of other, right? In this case, this is going to be other. So because it's the right-hand side of the plus sign, if the type of other is in fact the type of 1, well, 1 is an integer, so in other words, if other is an integer, then I'm just going to create the numerator and denominator myself, and I'm simply going to say, well, the numerator is equal to self, because what does this mean here? This is really the case of 5 over 1, right? 5 is going to be 5 over 1. So the numerator is going to be other itself, and the denominator of the other is going to be a 1. And when I do the arithmetic, I basically get this over here. And so I get a numerator, and the denominator is going to be what? How do I get the denominator? I basically going to multiply the denominator of the left-hand side, which is going to be self.denominator, times 1. So that gives me just simply self.denominator. I then find the greatest common divisor between the two, just as before, and then I divide them and by the greatest common divisor, and then I create a rational number that I return. So that's how I treat the case of a plus 5. So now I can add two rats, a and b, and I can add a rat and an integer. Okay, and before we finish with the rat addition, I just want to point out there's actually a better way. There's an easier way to do this particular operation of adding a constant a 5 to a rat a, and that is if I realize that the right hand side is going to be an integer like this is, so instead of all this it's not so complicated, but instead of all this long code, I can simply write the following thing. If type of other is equal to type of integer, then all I need to do is I need to say I'm going to return what? Well, I'm going to say return self plus, well, other is an integer, and if I say self plus rat of other, this will actually work as well, and this is much simpler. Now, why does this thing work? Because what's going to happen is it's going to call the plus function that we have defined over here. So the plus function, there are two plus functions. The plus first checks what about the right hand side to the plus function. So when I say rat of other, what this is going to do is it's actually going to take rat, it's going to take other, which is an integer, and create a rat out of it for me. So it's going to create a rat that has other as the numerator, right? It's going to look like this. Rat is going to take the rat as a numerator. This is going to be other. And it's going to put a 1 over here, but this is going to be in fact a rat. Self is a rat, right? Because the left hand side here, A, is a rat. And so what it's going to do is it's going to immediately jump down over here, and it's going to use all the machinery that we've already built. So instead of all this complicated stuff, we can simply say if the type of other is equal to type of 1, once we detect that, then this becomes, this will actually work. This in fact is much nicer, it's cleaner, it's simpler, and it employs an important principle in software design, namely software reuse. If you've solved a problem at one point, if you can use that solution to solve another problem, then you should do that. Okay, that's basically the idea of defining these rational numbers and how to do some simple arithmetic, namely adding those two rational numbers.